So this video lesson is looking at single displacement reactions. So predicting whether a single displacement reaction is actually going to happen and what the products are going to be for a single displacement reaction. So in order to predict products for single displacement reactions, we need to use some pictures, and it's really just a chart that is called the activity series. So that's what these two charts at the side of my page here are. So we need to have the activity series available to you. And you guys have a copy of the activity series on your periodic table booklets, but I also will post a copy of this specific activity series. And if you're ever looking for one, you can always Google search activity series for metals or activity series for the halogens, and you'll be able to find one very easily just by Google searching for it. All right, so if we're looking at single displacement reactions, we know that single displacement reactions involve having an element that's by itself and a compound, and they react to produce a different element by itself and a new compound. And so in this, there are single displacement or single replacement reactions. A comes in and takes the place of B, so that B is then by itself, and now A is in a compound with whatever C happens to be. So these are our single displacement reactions. Now, with single displacement reactions, sometimes the reactions don't occur because A is not actually able to replace B. So we're going to look at some actual examples of reactions and figure out what the products will be and or if the reaction will even happen. So we're going to start with this one. We're going to have some iron, and our iron is going to react with copper 2 sulfate. So it's reacting with CuSO4. Okay, so in this reaction, iron is going to have to kick out copper so that the iron is with the sulfate, and the copper is going to end up being by itself. So we're going to, hopefully, if this reaction happens, the iron is going to displace the copper. And the reason we know the iron will displace the copper and not the sulfate is because metals will only displace metals. Non-metals will only displace other non-metals. So it has to be a metal replacing a metal, or a non-metal replaces another non-metal. And so we have to look at our activity series to see if iron is actually reactive enough to replace copper. So we're going to look for iron and copper on our activity series. So I've got copper right here on my activity series, and then I've got iron up here. Now, since iron is higher on the activity series than copper, iron is able to replace copper. So we're going to create this iron 2 sulfate and our copper. Okay, so we'll create iron 2 sulfate, and we'll also create copper. And the reason we know that that will happen is because iron was more reactive than the copper. It was higher up on the activity series, so it is actually able to replace copper. So let's look at another example. So this time we're going to have a nickel, and it's going to react with sodium chloride. Okay. So if this reaction is going to happen, my nickel is going to have to replace my sodium. So I need to look for nickel and sodium on my activity series. So I have sodium up here, and I've got nickel down here. All right, since nickel is lower than sodium, nickel is not going to be able to replace the sodium. The sodium is more reactive than the nickel, and so the nickel is not going to be able to replace it. So we're going to have no reaction. So this reaction will not actually occur. Okay, let's try 2 more examples here. So we're going to look at reacting lithium with zinc carbonate. Okay, so we're going to try and react lithium with our zinc carbonate. So if this reaction is going to happen, lithium is going to have to replace our zinc. So we need to look for zinc and we need to look for lithium on our activity series. So we've got lithium up here right at the very top, and then zinc. And so lithium is more reactive than our zinc. So lithium is going to be able to replace our zinc. So we're going to create lithium carbonate. You got to be really careful about creating the formula for lithium carbonate because lithium has a +1 charge, but carbonate has a 2- charge. So you got to make sure we're using our crisscrossing rules. And then we're also going to create some zinc. Okay, so lithium was able to replace zinc because it was higher up in the activity series. Let's try one more example, only this time we're going to look at replacing a nonmetal with a different nonmetal. And so we're going to have some chlorine, and we're going to react it with aluminum bromide. Okay, so in this case, because we have chlorine as our single element, chlorine is going to try and replace our bromine. Okay, so our aluminum is not going to be replaced. It's going to be the bromine that's replaced because chlorine is a nonmetal. Nonmetals can only replace other nonmetals. And so in order to do this, we're going to have to use our different activity series, which is just the halogens. So group 7 or group 17. And here we're going to look for chlorine. So we've got chlorine here and we've got bromine. And the same rules apply. So chlorine is higher on the activity series than bromine, which means it's more reactive. So it is able to actually replace bromine. So we are going to make aluminum chloride. And now bromine will be by itself. Let's actually try one more of those where we are not actually able to do the reaction. So say we have iodine reacting with, let's just do sodium chloride. So in this one, our iodine is going to try and replace our chlorine. So we have chlorine up here, right? We've already found chlorine. But then iodine is farther down on the activity series, which means iodine is not going to be able to replace the chlorine because it's not as reactive as the chlorine. So we're going to have no reaction here. So we'll predict absolutely no reaction happening with if iodine tries to replace our chlorine. Okay, so when you're looking at single displacement reactions and you're trying to predict the products, you always want to use your activity series. And the only way the reaction happens is if whatever is trying to do the replacing is more reactive than whatever is being replaced. So we need to have a more reactive metal replacing a less reactive metal, or a more reactive nonmetal replacing a less reactive nonmetal. If it's the other way around, then we will get no reaction. So our examples like this nickel and sodium chloride, or example down at the bottom here of this iodine trying to replace that chloride. Okay, so the iodine is less reactive than chlorine, so it's not able to replace it. So no reaction. Our nickel is less reactive than our sodium, so it's not able to replace it, so we get no reaction. Okay, that's it for predicting single displacement reactions. The only thing you should always double check and make sure that you do still, even with single displacement reactions, is once you've got the reaction, you should think about balancing it out, just to make sure that you have a now balanced chemical reaction.